Welcome to lesson 6.2, where we get to learn lots of integral rules. You have much memorizing to do for today's lesson. So here are a bunch of new integral rules. Although they're not really new, they're just backwards of what we were doing before. So for example, integral of secant squared is tangent because the derivative of tangent was secant squared. So we're just kind of going backwards from all the rules we've learned before. Now, the most common errors happen with sine and cosine. So this chart right here might help you memorize these. You'll notice it kind of looks like the unit circle because if you remember, cosine is your x value. So this would be positive cosine, this would be negative cosine, positive x, negative x. Sine is your y value, so this would be positive sine, positive y, negative y. So we kind of create this, and then we can remember that if we want to take derivatives, we go clockwise. So the derivative of sine was cosine, and the derivative of cosine was negative sine. If I want to take antiderivatives, I go anti-clockwise right here or counterclockwise. So if I want to go take antiderivatives or integrals, I go counterclockwise or anti-clockwise. So the integral of cosine is sine, and the integral of sine is negative cosine. So hopefully that helps with those two rules. Anyway, let's go through and start to apply all of those different rules that are listed with number 1. And we're still going to be using those other rules we learned before. So first off, we're going to start with our scalar multiplication rule by taking that -3 outside of my integral. And now I want to do the integral of sine. So I think of my little thing, here's my sine. And remember, integration goes counterclockwise. So that's going to be negative cosine. And don't forget our constant of integration plus c. So altogether, when I simplify this, I should get 3 cosine of x plus c. Okay? Let's try number 2. We're going to start by separating this like that, just like we learned in the last lesson. Now, if you look at your integral rules, the integral of e to the x is itself because the derivative of e to the x is itself. So that's just going to be e to the x minus derivative of 2 to the x is going to be 2 to the x divided by ln of 2 of whatever the base is, plus our constant of integration. Okay, let's try number 3. So let's separate this first. So we got 5. I'm going to change this to t to the 2/3 so that I can use my power rule on it. dt plus the integral of 3 cosine of t dt minus the integral of 1 dt. Okay, you should be able to try this one on your own now. So I want you to pause the video. Here I'm going to take our scalar multiplications out. Pause the video, and this is going to use our power rule, our cosine rule, and our constant rule. And then come back and see how you did. Welcome back. Check what you got with what I got. So I started right here, which if it's a free response, you can leave it there. If it's multiple choice, you're going to want to simplify it. So 2/3 plus 1 is 5/3. And then we don't like to divide by fractions, so I did my leave, flip, change rule, where I leave the numerator, flip the denominator, change division to multiply. And when I did that, I have a 5 on top and a 5 on bottom. That cancels out, so I'm just left with 3t to the 5/3. And there's the rest of it. So there you go for number 3. Let's try number 4. Now, this number 4, this is actually a 1/4 times secant y tangent y. So that is a scalar multiplication where I can just take that 1/4 out, and then I'm left with my equation, which we can just look at our integral equations that you're going to need to memorize. Secant y tangent y, the integral of that is just secant. And then my constant of integration c. Okay, last one, number 5. This one has an initial condition. So this is going to be our 2 steps where we find the integral and then plug in our initial condition to solve for c. So first we're going to find the integral of cosecant of x squared dx, which, by the way, is the same thing as cosecant squared x. Those are the same thing. So I want you to try this one. Find the integral of this plus c, and then plug in your initial condition to solve for what c should be. And then come back and see how you did. Let's see how you did. We have an integral rule for cosecant squared. It's cotangent, well, negative cotangent, plus c. I'm going to plug in my initial condition, so I get negative cotangent of 5π4 plus c equals 3. Here's my unit circle. There's 5π4, and there's the point. Cotangent is x over y. It's the reciprocal of tangent. So my x value divided by my y value, well, that's just going to be positive 1. But then I have this negative on the outside, so that's why it's a negative 1. Plus c, solve that, get c equals 4. And then I plug it in to get my equation. And that is all for 6.2. You should be able to get started on your assignment now.